Hi guys, I got a request to talk about the scalar multiple rule and also the sum and difference rules for derivatives. Both of those look a little intimidating, I think, when it's kind of written out in general in kind of math terms. But really what it means is that if we have any function that we can find the derivative of, if we have a similar function where it's a scalar multiple of that function, then the derivative is just the derivative of scalar multiple of the derivative of that function. So I'll show you an example. So for instance, if f at x equals x to the exponent 5. So if we have that, that function, which we obviously know using the basic power rule, that the derivative of that would be 5x to the exponent 4. So if we had a related function, so say g at x, if g at x was a scalar multiple of the function f at x, so let's say 3x to the exponent 5, then the derivative of g at x, or g prime at x, that this would be 3 times the derivative of x to the exponent 5. So this would be 3 times 5x to the exponent 4. And we'd simplify that to 15x to the exponent 4. So it's just kind of saying that if you have a scalar multiple in front of any kind of thing that you know how to take the derivative of, you just take the derivative normally like you would of the simpler function and then multiply the derivative by that scalar multiple. Now, normally we would never really show that middle step. We would just go right to 15x to the exponent 4 in that one once you get comfortable with the derivative rules. Another kind of similar example is if we knew, let's say, f at x equals x cubed and g at x equals x to the 7, just using some really simple little functions here, but this is going to be true for any function that we can find the derivative of. Then we know that f prime at x is 3x squared and g prime at x is 7x to the 6. So if we had a combined function that was the sum or difference of these two smaller functions, for instance, h at x, if I need that x cubed plus x to the 7, then the derivative of h at x is just the derivative of f at x plus the derivative of g at x. So you can take the derivative of terms in the function that are added or subtracted just by taking the derivatives of the individual terms and then adding and subtracting the derivatives. So that would be 3x squared plus 7x to the 6, so that you can take the derivative of one piece and the derivative of the other piece and just add them up or subtract. The same is not true if you have components of a function or pieces of a function that are multiplied or divided. We're going to, in chapter 5, learn some special rules called the product rule and the quotient rule that, that you'll need to be able to do the derivative of functions where there's two functions multiplied by each other or divided together. But for now, if you can take the derivative of an individual piece of the function, whether they're added or subtracted, you just do the derivative of each piece and keep the plus or minus in between those terms as needed. And again, the derivative, the scalar multiple rule, just means that if you know the derivative of a piece of a function and it's multiplied by a scalar, not by some other function, just a scalar real number, then you can take the derivative and multiply the derivative by that same scalar.